Okay, so let's talk about what was going on in the elevator activity. So here you can see all of the positions of the elevator ride, 1 through 9. And you'll notice that at positions 1, 3, 5, 7, and 9, all of those free body diagrams look exactly the same, and the system is in equilibrium at those positions. So 1, 3, 5, 7, 9, we see a net force of 0 and an acceleration of 0. Now, these free body diagrams could describe two different situations. The elevator could have been at rest, like it was at positions 1, 5, and 9, or the elevator could be moving at constant speed, like it was in positions 3 and 7. As the elevator was moving upwards and speeding up, that means that acceleration points up. So now we're talking about position 2. So in position 2, the elevator was moving up, speeding up. Acceleration points upwards, and so we know the net force must be upwards. That means that the forces pointing upwards must be greater than the forces pointing downwards. So here we see a normal force that's greater than the weight force. Now that exact same condition is occurring in position 8. In position 8, we see an acceleration pointing upwards and a net force pointing upwards. Therefore, the normal force is greater than the weight force. However, position 8 describes a different situation. In position 8, the elevator was moving downwards, slowing down. So again, position 2, elevator was moving up, speeding up, and position 8, elevator was moving down, slowing down. So in both situations, the elevator has an acceleration pointing upwards. However, the elevator is doing two different things, either speeding up in position 2 or slowing down in position 8. But you'll notice that the free body diagrams are the same. Now in positions 4 and 6, we see that the normal force is less than the weight force. So the acceleration here clearly points down. The net force also points down. And this is also a result of two different situations. In position 4, the acceleration and the net force point down, and the elevator is moving up. So in position 4, the elevator is moving up, slowing down. So V points up and A points down in position 4. In position 6, the elevator is moving down, speeding up. So V points down and A points down. But you see that the free body diagrams are exactly the same for positions 4 and 6. So one of the big takeaways from the elevator activity was that you really can't tell that much just by looking at a free body diagram. All you know from a free body diagram is the direction of the net force and the direction of the acceleration. Now, unless you know the velocity of the object or you know what the system is already doing, you really have no idea whether that system is speeding up, slowing down, or in the case of equilibrium, positions 1, 3, 5, 7, and 9, you don't even know if the object is in motion.